Geological processes that occur beneath the waters of the sea affect not only marine life, but dry land as well. The processes that mold ocean basins occur slowly, over tens and hundreds of millions of years. On this timescale, where a human lifetime is but the blink of an eye, solid rocks flow like liquid, entire continents move across the face of the earth, and mountains grow from flat plains. To understand the sea floor, we must learn to adopt the unfamiliar point of view of geological time. Geology is very important to marine biology. Habitats, or the places where organisms live, are directly shaped by geological processes. The form of coastlines, the depth of the water, whether the bottom is muddy, sandy, or rocky, and many other features of a marine habitat are determined by this geology. The geologic history of life is also called paleontology. The presence of large amounts of liquid water makes our planet unique. Most other planets have very little water, and on those that do, the water exists only as perpetually frozen ice or as vapor in the atmosphere. The Earth, on the other hand, is very much a water planet. The ocean covers most of the globe and plays a crucial role in regulating our climate and atmosphere. Without water, life itself would be impossible. Our ocean covers 72% of the Earth's surface. It is not distributed equally with respect to the equator. About 2/3 of the Earth's land area is found in the northern hemisphere, which is only 61% ocean. About 80% of the southern hemisphere is ocean. The ocean is traditionally classified into 4 large basins. The Pacific is the deepest and largest, almost as large as all the others combined. The Atlantic Ocean is a little larger than the Indian Ocean, but the two are similar in average depth. The Arctic is the smallest and shallowest. Connected or marginal to the main ocean basins are various shallow seas, such as the Mediterranean Sea, the Gulf of Mexico, and the South China Sea. Though we usually treat the oceans as 4 separate entities, they are actually interconnected. This can be seen most easily by looking at a map of the world as seen from the South Pole. From this view, it is clear that the Pacific, the Atlantic, and Indian Oceans are large branches of one vast ocean system. The connections among the major basins allow seawater, materials, and some organisms to move from one ocean to another. Because the oceans are actually one great interconnected system, oceanographers often speak of a single world ocean. They also refer to the continuous body of water that surrounds Antarctic as the Southern Ocean. The Earth and the rest of the solar system are thought to have originated about 4.5 billion years ago from a cloud or clouds of dust. This dust was debris remaining from a huge cosmic explosion called the Big Bang, which astrophysicists estimate occurred about 15 billion years ago. The dust particles collided with each other, merging into larger particles. These larger particles collided in turn, joining into pebble-sized rocks that collided to form larger rocks, and so on. The process continued, eventually building up the Earth and other planets. So much heat was produced as the early Earth formed that the planet was probably molten. This allowed materials to settle within the planet according to their density. Density is the weight, or more correctly, the mass, of a given volume of a substance. Obviously, a pound of styrofoam weighs more than an ounce of lead, but most people think of lead as heavier than styrofoam. This is because lead weighs more than styrofoam if equal volumes of the two are compared. In other words, lead is denser than styrofoam. The density of a substance is calculated by dividing its mass by its volume. If 2 substances are mixed, the denser material will tend to sink and the less dense will float.